Okay, let's get started today. Welcome back. I hope everyone is staying safe and staying home and following directions of providers and the CDC. It's important to continue with our class content, and since this has turned into a project class for the last half, to give you a quick outline of what we're going to do before we go into the actual content today, is what I want to do first is go through a couple of lectures that will help you with your project. So today I want to talk about design and development cycles, a little bit about software engineering. And then next class I want to talk a little bit about using a versioning system for your project. So that will allow you to work remotely on the same project much more easily. This will help you with refining your design a little bit. So this week we're going to cover some things that should help you directly with your project as far as managing it, as far as completing it. And that's what I want to do today. Now, what I want to do after that is I'm going to go through some special technical topics that will maybe help you with parts of your project. So I've got things like saving more complicated data to files, physics simulation, applying forces to things in physics simulation. So there's a whole list of topics there, but I'm going to kind of go through those early on, and then after that, what I want to do is work on mostly communicating with you, giving you time to work on your projects, having you be able to work together remotely on that. And I would encourage you guys to, as questions come up, to get in contact with me. As far as things like office hours go, and as far as things like asking questions, my cell phone number is on the syllabus on the course page. Feel free to text me or call. Also, email is always good. You can send me email, and I'll try to get back to you relatively quickly if possible. But the main thing right now is let's get through these lectures this week, and then we're going to do our topics over the next few classes. I might spread those out a little bit, but I want you to focus on your projects. So let's get you the things that will help you with your projects first. All right, so the thing we're going to cover today is kind of design and development cycles and a little bit of an introduction to software engineering. And the main things that I want to get through today hopefully will help you with planning your project, with doing things with that. Now, what we're talking about with design and development cycles is basically something that will help us with building a game. And building a game or a simulation, or really any software, large software project, can be a huge undertaking. And it requires a whole lot of things to kind of come together all at once. So we've got all of these things that go into making a game. And here's kind of a partial list of those. So we have kind of the ideas, the concept, what's the goal, what's the function of the game, how does it look, how does it feel, how do you interact with it. So there's a whole lot of things that that are kind of idea based. And we have kind of maybe a story. Some games have a story, some don't. Some kind of partially do and partially are more arcade. But if there's a story, that needs to be part of the project. The algorithms could be from something simple, saving files, loading files, to something complicated like computing real-time weather systems for some multiplayer game. Music and sounds obviously are important. Levels, if there are multiple levels, if there are models, if there are textures, what code libraries and modules need to be used to make the code work. And then obviously all the programming and scripting that go into pulling everything together into this one large project becomes something that is needs to go into that game. So the idea is that there's this complicated thing with a lot of moving parts. All of those things need to come together in a cohesive way. And at the end of the day, it needs to work. And so that's a huge undertaking. It can be fairly complicated. Now, some of those things that are on that list are abstract. So things like the concept of the game or the story or the goals. Those are not like physical things. Those aren't like things that you have to build. Those are more, I would say, fuzzy or abstract things. But some of them are clearly concrete and specific. For example, music. If you want to have music in your game, the idea of music is kind of abstract, but the actual music you need to deploy the game is a real thing. Same thing with the models and textures and images and sounds and all of the other stuff that go into making it. So any of those assets, and then obviously the code itself is a real thing. You're going to write that. It's going to be in the machine. It's going to allow the computer to do what it's supposed to do, to breathe life into that game or the abstract ideas above. So those two groupings, we can think of them as what things can be in our heads or on paper. And like obviously the concept and the story, we could storyboard those or write them out or kind of put them on paper, or just if we don't want to write them on paper, we could still have this really strong idea in our heads of a really well-defined idea of what those are supposed to look like. And the other side of the coin of that, with the concrete and specific things, are what things are real and need to be built or made and or acquired in order to have them. So real things we're going to need to either, for like code or assets, we're going to need to acquire them, make them ourselves, write the code ourselves, use modules that somebody else has written, but we're still going to need to get those and understand them and learn how to use them. And other things are going to be more abstract. Now, the reason why it's important to divide those things into those two categories is that the abstract things, those are relatively easy to change. It's easy to modify and evolve things like the idea quickly. So in other words, if you have an idea, it's very easy to change your mind. You say, okay, well, here's what I think I want to do, and then you think about it a little more and say, no, I'm going to do something a little different. So if it's on paper, or if it's in your head, or even if it's in an electronic form in a document that you're working on, it can be very easy to change those. But real things take time and effort to change or recreate or acquire. So those real things, like let's say you spend 4 days writing the musical score for your game, and then you record it. You spend another 2 or 3 days recording it and getting it exactly how you want. But then you decide you don't like it. Well, you have to go back and redo all of that effort. It might be you can do it a little bit quicker the second time. Same thing with coding. You spend a lot of time writing code for some sort of module that does some particular algorithm. And then you decide, you know what, I want this game to be totally different. All of that work is kind of lost. You have to start over and do this stuff again. So given that, good developers tend to start with the idea and the design and the plan first. And the reason for that is because why spend a lot of time and effort building something that you're going to throw away and have to rebuild? So the more work you can do up front with the idea and the more changes you can have early on when it's still in the idea stage before you put a lot of effort into building, the better. So good programmers start with planning, building, and then making a minimum working prototype first, rather than polishing up something and spending a lot of time polishing it when you're going to eventually make changes to that. So in other words, we want to upfront do as much of the abstract work as we can. We want to do as much of the idea work as we can. And then that way, when we have a really strong sense of the idea and we're pretty certain that that's what we want to build, then we start building that. Now, that's really similar to other engineering projects or other design projects. So as an example, think of like a architecture of a building. So you're going to build some structure. So the idea there is you don't want to just run out there onto some site and just start pouring concrete and slapping things together and then realize what you're building is wrong or it's not to code or it's not really fitting the design. What you want to do is again, as much of it on paper up front as you can. So the goal of the building, the idea, the use of it, what's it going to be used for. Clearly, there's a different set of guidelines for a factory building than there would be for an apartment building. So the use of the building is going to be important. And then once you get kind of that goal or idea or the main use, then you start with the initial kind of design sketches or an initial rough set of plans. So those plans at that point don't necessarily have all of the wiring diagrams and all of the details. It's more of like, this is kind of a rough idea of what it is that we're going to try to build. And it might have some sketches so people can see, you can convey that to other people. Or maybe it's just sketching it out to convey it to yourself. because sometimes what you have in your head might be different than what shows up on paper. And so there's this idea of kind of making these initial sketches, adjusting those when you can. In other words, keeping it at that abstract level and making changes then is really cheap and easy. But then we move into schematic drawings and plans. Essentially, we get to the kind of detailed design documents, or kind of design development phase, DD phase, and blueprints. And then eventually you might create 3D models and 3D renderings, or you might create physical models where you cut things out and build them, and then you look at it in a physical representation. And then eventually you refine the design documents to match anything that has ideas that have changed or things that you have thought of while you were looking at the models, the 3D renderings, the design documents. Or maybe you need to adjust things based on a site plan. But the idea there is all of that happens on paper. And when I say on paper, it really is a combination of electronic. But in this case, we're talking about not a real thing that's been built yet. This is all ideas and designs and plans. And so the idea is that in architecture, you do all of that as much as possible up front. Now, once you're done with that, or you get to the point where you're relatively certain it's stable, then you start on the real stuff. You have to do site preparation, build the foundation, perform all the construction kind of from the ground, working your way up. And so the idea there is that we now have a set of plans to go off of. We're not going to change a whole lot of things once we start building. Now, there may be some changes as we go, but we don't want to make major changes once we've started building the thing, unless we realize what we're building is completely inappropriate or unworkable. And then maybe we go back to the plans and refine the plans. But the idea is that building keeps us focused on something very specific, something very concrete, no pun intended. But the idea there is that we don't want to be kind of building as we go and making it up as we go along. We want to have a good plan for that. And essentially when we finish up, we have this assessment and sign off in an architecture project where, okay, everything looks good, it all matches the plans. Now we're ready to say that, yes, this project is done. Now, in that building example, you might note that a lot of people would need to be involved. And those people might have different roles, they might have different responsibilities, but they're all going to be interconnected. And so communication becomes really important, that the people who are responsible for the electric diagrams need to understand where the walls are. The people putting the walls where they need to go need to understand things about the use of the space. And the use of the space is determined by the needs of the client who's actually getting the thing built. And so there are a whole lot of interconnected things. The sprinkler systems, the plumbing, the electric, the walls, there are codes involved, so building code involved. So there's a lot of people that need to be involved. And that's that communication being important. That's where the good plans come in. So a good plan for a project like that is really important because it makes sure everybody's on the same page, that everybody's working towards the same goal. Everybody knows what it is that they're trying to build and what it looks like. And so without a good plan, even if you have really talented workers and really talented crew, you're not going to build the thing that you think you're going to build because nobody will know what it is that they're building. Everybody will have a different idea in their head. So in other words, the purpose of a plan is to take those ideas that were in your head and move them into this kind of concrete, crystallized form of the basic of the idea. And if anybody who's on the team looks at that plan, they should be able to then put that same idea. So it's, in other words, it's a way of sharing the idea so that everybody has the same kind of concept of that abstraction of what it is we're going to do. And at that point, it's very cheap and easy to make changes. Somebody's going to say, oh, you forgot a bathroom on this floor. We'll add it in on the plan. That's a lot easier to do then than after you build the building. You're like, oh, we forgot to put a bathroom here. Let's go back and redo a bunch of the construction to make that happen. That becomes expensive. Now, in game design and development, and actually in architecture as well, there's called design documents. And so the idea there is that for any major software development project, we want to have this good set of design documents that we're working from. Now, one thing is there is a balance there that you don't want to spend all your time on the design documents and never getting to the point where you build something. So there is, especially if you have a small team who are tightly knit, focused, you can get by with less of a detailed set of design documents. But it's still important that everybody's on the same page. If somebody thinks you're building an arcade game on your project and somebody else thinks you're building a real-time strategy game, or if you're building assets that have one kind of art look and it doesn't match with the rest of the project, then you're going to have something that does not what you want at the end. So it's important that everybody's on the same page and the design document should reflect what it is you're trying to build. Now, a quick quote here from Pablo Picasso is that goals can only be reached through the vehicle of a plan. There is no other route to success. That certainly fits with a large software development project like a game or a simulation. That if you don't have some kind of plan, then it's hard to have any sort of success come out of that. Especially for the larger the project gets, the more complicated it gets, the more important it is to have that plan and have everybody on the same page. And even with a small team, we still need to have some sort of really good communication of what it is that we're doing. And it makes the most sense to do that up front. And then everybody can divide up and work on their respective parts of that because everybody now knows what it is they're supposed to be doing. Okay, so let's take a quick dive into what makes a good design document. So good design documents need to have some detail in them. And they need to be detailed enough to communicate kind of the abstract ideas of the project. Sorry, the camera's moving. There's a cat here. She's trying to get in the frame. Okay, stop. Ow, she hit me. All right, so anyway, we want to have it be detailed enough to communicate the abstract parts of that project. Now, what we don't want, though, is we don't want to have too much detail. So you can have, remember that design document is to kind of communicate the ideas and those abstract parts of the project. We don't want to have so much detail that it locks us into a bad idea or a wrong path early on. And we also don't want to waste a whole lot of time and resources on something that might change later. So the idea is we want to start with this kind of initial design document and then start as the idea becomes more and more certain or more and more specific. Then we want to work on kind of refining parts of that as we can. In other words, once we get to the point where we're sure about something, then we can add details to that. The other thing is that we want to make sure the plan itself is kind of this sounds a little weird, but the plan needs to plan for change and evolution of the project. In other words, you might start building parts of this after you think you're certain about something and realize that, hey, the way that we wrote this, I don't know, battle system really isn't any fun. It's really bad. Let's redo that part of it. So you go back and change the plan, change the project, or you might realize this part of the story just doesn't make any sense with the rest of it. And so let's take that part out, or let's rewrite that part and redo that part. So we want to have the plan itself be able to be kind of a living document, not something that's prescriptive, not something like this is exactly what we're certain we're going to do. And everybody on the team needs to be comfortable with the idea that, hey, if they realize that part of the plan is bad or wrong or incomplete, we're going to modify that plan. It needs to be thought of as a living document more than a kind of rule book that has to be followed. Now, you can't just go off and change things, though, either. If you're on a team, you need to talk with the team about how the plan needs to be changed. The other thing is that flexibility, a summary of that is it needs to be adaptable and it needs to change with the vision of the project or the scope of the project. But note that there's a balance there, that it needs to have enough detail, but it can't have too much detail. If you have too much detail, it can lock you in, waste time on a document rather than building. And if you don't have enough detail, then everybody isn't on the same page. So again, think of it as a communication mechanism. Now, the phases of development, what we're talking about with phases of development is essentially, if you have a large project, you can think of it as kind of this multi-phase process. In other words, we start with this design phase, just like with an architecture project, and then that results in plans. And then we work through this kind of prototyping and investigation phase, and that we could think of as kind of modeling. In other words, prototyping we might think of as making a really rough, maybe technical demo where we test out some of the ideas in the plan and make sure it's possible to do them that way. Or we might make sure that it works the way we think it's going to work, because sometimes what you have in your head is different than how you think it will be is different than the way it will really be once it works. So the idea there is we want to take the plans, make the prototype from those plans, in other words, make the model match the plans, and then inspect it. And now, after we're pretty sure that the ideas are good, so in other words, the prototype is a way to ensure that the thing that you're about to spend a lot of effort building makes sense to build. And and it's also a way to make sure that the plans match what it is you think you're going to do. So then after you do the prototyping phase, a lot of time that will result in modification to the plans, things that need to be redesigned. And then after you're pretty sure that the prototype is good, then we start the actual bulk of the development phase, the build part of it. So again, back to architecture. Plans, you make a model, you look at the model, you refine the plans if necessary, and then once you're pretty certain that you're ready to build, then you start building stuff. Same thing with a large software development project. Now, again, changes are easiest and have the lowest cost in phase 1. They have the highest cost in phase 3. And so the idea there is that oversights, errors might be built into our plan. We might not know about them. You won't know about them until we make a model or until we start building. So the plan, again, should be adapted based on phase 2. And then phase 3, before phase 3 starts, before you start the bulk of building some large project, you should have a really stable notion of what the idea is and what parts are necessary and how it all comes together. And again, that's where the plan comes in. But it should be relatively stable before you start doing the thing. So you might still need to make a few changes, but the smaller the changes you need to make once you're in development, then the more quickly you'll get the project done, and the more likely it'll be to have a success and match what it is. So again, we want to have as much of the changes, the major changes that happen in phase 1, use phase 2 as a feedback mechanism. Phase 3, try not to make a lot of changes, but if they're necessary and the project will not succeed without them, then you have to make them in phase 3, but it can be more costly. You end up rewriting things, rebuilding things, restructuring things. And once you've already started building something, it's much more difficult to go backwards than it is to go forwards. Again, think of a building. If you're building a skyscraper and you build the 90% of it and realize you should have put a parking garage on the bottom, then it's really almost impossible to jack up the whole building and put a parking garage in where it was not designed to have one. Much more expensive that way than doing it up front. All right. Now, I would add a fourth phase to that process too. And the fourth phase that I would add, I would call assessment. In other words, assessment is where you say, okay, I built this thing and I think I'm done. Now let's go back and look at what it is we built and try to learn from either the success or failure of that. And that phase in software design and software development is sometimes called a project postmortem, where you basically, postmortem sounds like it's dead, but really at that point it's alive. So what you've done is you've breathed life into this project, and now you're going to look at it and say, well, did it match what I thought it was going to do? And if it failed, or if it was not exactly what you wanted, the question is like, why? What went wrong there? And so the reason why that's important is it allows you to learn from both mistakes and successes. It's important to know what went right and what went wrong. And the reason it's important to know that is if you don't understand what mistakes were made during the development, or maybe mistakes in the design itself, then you'll repeat them. You'll do it over and over again. You won't know that that's why it failed. And if successes aren't understood, then the same thing happens, but it might work and you'll think, wow, I was so smart, but you don't know, and that was great, but you don't know why it was great unless you understand what went right. And so it'll be difficult to replicate successes. You'll repeat mistakes. So in other words, it's really important when you go through a project to understand what were the good parts, what were the bad parts, what could we do better, what changes would I make for my next project. And I would add that on to the end of these so design, prototype, build, and then look at what you built, step back, take a look at it. And not just looking at what you built, but looking at the process that was used there and kind of investigating that. All right, so going on from there, To develop the design documents, there are essentially several phases that we need to think through. And the first one there is kind of creating the initial design outlines or design treatment. And the main part about that that's probably important to think through is the design outlines are often very abstract and very rough. Sometimes those are called a design treatment. In other words, it's just really just an overview. It says, here's the idea. Here's some of the key features. We don't have a lot of detail in there. You don't have, for example, if you have a storyline with subplots and things like that, none of that would end up in kind of the design outline, or very little of it would. You'd have an overview with key features. Again, the higher up in this list, that's where it's easiest to make changes. So if the ideas can be improved, then the idea should be improved early on before you have a whole storyline and everything built around it and have to throw that work away. Again, the idea here is to not waste time and effort on something that you're not going to end up building. Now, once you have that design outline, then you start kind of filling it in with some details. So that's where you wind up with this concept of what's called a preliminary design document. And the preliminary design document is kind of like the outline, but with some details filled in. What's the more complete? Instead of key features, let's have an entire feature list. Instead of having an overview of the idea, let's fill in the technical specs and the storyline. Let's list some of what are the settings? What's the user interface going to be? What's the system architecture? Is this a single player game? Is it multiplayer? If it's multiplayer, what things are on the server? What things are on the client machine? Is this a mobile game? If it's a mobile game, does it need to talk over the network to get new levels? Does it need? So in other words, you want to kind of have this preliminary idea. Now, from that preliminary design document, you might meet as a group or meet with a team and go through that, figure out what things you need to change, and then make a prototype from those preliminary designs. And the prototype might be one single level or a tech demo. It could be something relatively simple. It could even be several different kind of prototypes of different subsections. Here's how the battle system works. Here's how what the rendering looks like. Here's some initial artwork to show the look and feel of it. And the idea, again, is to then take what you learned from those prototypes and those initial storyboards and those early on kind of preliminary designs, and then look at that prototype and make changes. So the idea is that after initial prototyping, changes will have to be made. We're going to have to make some adjustments, or at least we probably should make some adjustments. And then the design documents should be thought of as a communication tool that is used to reflect those changes that are being made. So again, think of it as a communication tool, that it's a way of taking an idea, making sure from a lot of different people, putting it into one crystallized space so everybody can have the same idea and work towards the same goal. Now, when you get to the final design documents of this project, of any project, the idea is that at that point, you should be relatively certain what it is you're building. You should know with certainty that this is what we're going to be creating, and we still want it to be flexible and organic. So in other words, if we see something that's gone horribly wrong or going horribly wrong, we should fix it as we are building. But we don't want to be making major revisions once we get to the final design of the project. So the design documents are relatively stable, but not set in stone. Still maintain flexibility. Now, every level or subsystem might have its own design document set. So in other words, the battle system or the story or the server code might have its own design documents associated with it. All right, so why use design documents? The main reason is that they're going to act as the foundation for development. They're a way to make sure everybody has the same idea. Everybody's working towards the same idea. And the main goal there is that we want to save time and resources. We don't want to spend time building something that we throw away. We want to spend our time building the thing is that we want to build. And so, again, think of it as a communication tool that allows all of the members of the team to communicate with each other. And if everybody's communicating and everybody's on board with the design document the way that it exists, it acts as kind of this unified plan. And again, without a good plan, a good product is going to be impossible to make. It's going to be really difficult to make a good product without some sort of unified plan. One other thing that I like about having a design document is it acts as kind of a project to-do list. In other words, if you've built a good design document, a good final design document, then in that document is going to be kind of this list of features and this list of really even the kind of architecture and technical things that need to be built. And so you can use that as a to-do list to assign tasks to people to separate that out and actually track the progress of your development. So the idea there, start at the top, farm out the things to the different team members, and then have them start working on those tasks. And since you have it all in the design document, you can have people check back in. You can track the development progress relatively easily. All right, now, so that's kind of the first half of what I wanted to talk about today. And as a reminder, if you have any questions on any of this, feel free to text me, email me, or post questions in the comments section for the video, and I'll answer them as I can. Take a quick break here for you to switch gears here. But one of the things that I'm going to talk about next is kind of software engineering. And software engineering is more on the coding side of the project. And so let's just take a couple seconds here, gather our thoughts. I'm going to take a little drink and try to move the cat away from me. And then we'll dig into software engineering. And if you're interested, there's the cat. She's unhappy. Okay, software engineering. So software engineering is kind of the building the code part of the project. And there, again, this is distinctly different than the design document, but these different methods are associated with that. And so it's important to kind of note the interconnection of software engineering with the development of the design documents. And these different methods kind of work slightly differently. And a lot of these are kind of different ways of describing the same thing, but there's a distinct philosophical difference in some of them as well. So let's take a look at some of them. The first one, waterfall. Waterfall kind of, if you think of a waterfall having kind of multiple levels where it kind of starts at the top and then the water flows down, and there's another level and then it flows down. So think of like this kind of cascade vision there. So in other words, with waterfall, we start at the top and work our way down from requirements at the top level. So here are the requirements, and then that slowly works its way down through deployment at the bottom when the thing is done. Now, Agile is a little bit different philosophy that's rather than kind of flowing or cascading downward from requirements at the top down to deployment at the bottom. What Agile does is it works on that idea of making a model. So in other words, we have this kind of circle that we go through to make a working prototype. And then after we have that prototype, we look at what does the prototype not have in it yet. Here's a set. So in other words, you have this set of tasks. You work through, add it, that are requirements. You add the important ones first. You add more of them. And so Agile is kind of a iterative, cyclical process where you work in sprints that always result in working code. Now that's a different kind of concept than waterfall, where everything flows downwards. This is kind of more of a circle. And another way of visualizing that kind of agile cyclic process is the spiral method. There's also a method called DevOps, which is good for systems that require continuous improvement and changes. And then there's one called Rapid, which is also a lot like Agile and Spiral, but it focuses on really quick iterations, which is good for small teams when you have highly skilled team members. All right, let's look at each of those individually. The Waterfall Method. Waterfall Method is kind of what we would call a sequential development method. And Waterfall Method was started by really large companies working on really large projects. So the idea there is you start with the requirements phase. And the requirements phase, you get everything the project is ever going to need as a requirement. And then that moves down to analysis, where you look at the requirements and look at how you would design the thing. And then after analyzing requirements and maybe making changes to them, you work down to design. So the design is now taking what you having the requirements and what you learn from analysis, and now kind of designing the architecture of the project. And then after the architecture is designed, you might say, okay, I need these functions, I need these subsystems, I need these code modules. Then you build all of that stuff. And you can see why this would work for a large team is that it basically, the people in charge, the thing that drives the entirety of the project are the requirements and then the design, and then the code is just built. So in this case, the software developers are considered more of a commodity. You say, okay, here's the function you need to build it. And then after it's built and you implement it, then you test it, and then you deploy it. And then after it's been deployed, then you need to maintain that, make bug fixes, make changes to it. But one of the things you notice about this is there's no cycle involved. The waterfall never flows uphill. It never goes back and changes things at the top. It all flows from the top down. And that's why this is called a top-down development model. And this kind of development model, though, can be problematic because it doesn't have any feedback mechanism. In other words, if your requirements were dumb at the top, then that's just going to flow downhill. So kind of like if you have requirements that are really bad or wrong or non-optimal, then you're going to end up with a project that's non-optimal at the bottom. And so again, the time to make the changes is less costly at the top, but the problem with this is there's no feedback mechanism, really. It just works its way downhill. Now, I know people that work for places like Apple, and at Apple they have a model that's very compartmentalized like this. They have people writing code for functions and modules or developing hardware that they have no idea what it's ever going to be used for, and they might never know what it's going to be used for. They get a design document or a requirements document, and it says, build a function that you give it this input and it produces this output, and they have no idea what it does. I've also known people that worked at companies like Amazon, and that was very similar in the kind of large space that they're in. They say, okay, you have a thing you're supposed to build, you write this code or this object, and it works in these ways, and you're just given a document, and the programming is more prescriptive, that you're told what to build, you build it. Without understanding why or how. But for a game project or a project that is a little more flexible with a smaller team, that gets to be problematic. So the advantages of this are that it's linear, it's top-down, it makes it easy to divide it across a very large team. But the problems with this, no feedback mechanism. There's no way to have the requirements easily change based on what the programmers have discovered. And a lot of times you won't know the right way to design something or build something till you're partway through building parts of it or till you make a model of it. Notice there's no prototyping phase in here with a feedback mechanism to change the requirements or the design. That's a problem. So this is kind of the old school way of doing software development where programmers are thought of as a commodity. But the more recent way that development happens and a little more realistic thing. Essentially, a group got together. They said, rather than following this kind of top-down model that we have in this waterfall model, what if we made a model that works like successful programmers work? So in other words, let's kind of capture the way good programmers and good developers develop things, and then we'll make it a little more formal. And so the idea behind Agile is rather than making it as this top-down model, it's kind of this iterative model. So if you notice there, we have this kind of loop where it loops back. So it starts with kind of what they call in that diagram their product backlog or a feature set, similar to the requirements that we would have in a waterfall model. But then the next step of that is we take parts of that product backlog, the features that we want to have in our project, and we kind of create what's called a sprint from a certain subset of those. In other words, we have a set of features that say these are the most important ones to get done early on. And then what you do is you make a working prototype from that. In other words, you take those features, you implement them completely into a working set of code. Notice that back in the waterfall model, we don't really test until everything has been coded. In this, we take a little bit of the requirements, we code just enough of that, so we plan that, we implement that, and then we review it. And then after we review that, there's this thing it's called retrospect there, where we look at what it is we built so far, and then we make changes there if we can. So in other words, you start with like a minimum set of functionality, you get that working, and then you look at it. You look at it really hard and say, is that what we want to have happen? Because if it's not, we need to change it now. Because once we've added layers and layers of code on top of this simple thing, it's going to get harder and harder to change it. Again, think of a building that you're building with a foundation. We build the foundation. If the foundation needs adjustments, we do that now rather than later. Now, notice in there that's what they're calling a sprint. Those are usually divided up into a certain length of time. Like it might be 10 days, it might be 30 days, it might be a week, it might be 7 days. But a sprint is basically say, here's the list of features we want to add this week or this month. And then at the end of that week or month, then we're going to look at that. We're going to make the plans for what we're going to add next. Now, inside of those sprints, though, notice there's that thing that they say daily scrum that has that little loop inside of there. That means that every day we're going to look at how far we are, what features we have in this current sprint. Is everything on schedule, or is there anything blocking anyone from getting this on schedule at the end of our sprint session? So the idea is we're going to then go back to planning again and take the next things on the product backlog, pull them in, add those to the process by going through that next iteration of that cycle, having our daily meetings. Sometimes those daily scrums are called stand-up meetings or daily stand-up. And the reason they're called stand-up is it's not a meeting where you get together in a boardroom and everybody sits down and you spend 3 hours on just talking about stuff. It's called a stand-up because you go around to everybody on the team and you say, where are you? What's blocking you? What progress have you made? Is everything on track? And that way everybody knows the state of everyone else. So there might be a case where somebody says, oh, I need to change this part, or this part's causing me problems. I need help from you. I need to understand that. So it's a way for everybody to communicate in a kind of very quick, dynamic way where everybody... And the reason why that's done as a meeting rather than an ad hoc approach is that way everybody can focus on building stuff and working on stuff for the majority of the day without being interrupted. And programming is one of those tasks where you need to get in a certain mindset and just kind of flow and write the code and build the stuff. And if you're constantly interrupted by other things and other questions, then it gets difficult. You get your mind around what you want to do, and then somebody asks you a question. So it's one of those things where having the daily scrum at either in the morning or at lunchtime, right before lunch, is usually a good idea. So that way everybody can focus large blocks of time on building, daily scrum, and then back to building again. And then once we're done with the sprint, everybody pulls new things off the backlog. And eventually what you'll have is all the things on the backlog will have been completed. And it will match what you want because you've adapted it every step of these sprints along the way. And then you'll have something that's done. Now, there's advantages of this are clearly that it's more flexible. It allows changes to happen more rapidly. The disadvantages of this are sometimes the thing that you end up with being produced does not match what your original design was, but that's not necessarily a bad thing. The other disadvantage of this is it can be considered more problematic if you have an unskilled team of developers. That, for example, if one developer gets stuck on one part of that backlog and it holds up the whole sprint, then since this cycle feeds into the next cycle, it's going to delay the entire project. So you have to have a relatively skilled team of developers who are good at communicating with each other in order for this to work. And back to this, communication skills are sometimes not the best with programmers or engineers. So this is for a group of developers that are good at this, though, this can be really, really advantageous. Now, another way of looking at that is called the spiral method. And the spiral method combines elements of both waterfall and agile. In other words, it's not really agile. It does have a cycle because if you start at the middle, that's ground zero. That's where the project starts. And what it does, though, is it divides up each of the cycles of kind of this sprint that we had before. It divides those up into kind of individual elements of the waterfall method. In other words, you start out with kind of like this notice that quadrant 1 that's labeled 1 up there, determine objectives, identify and resolve risks, development and test, plan the next iteration. Very similar, and it's a cycle, but notice that it's more formal in the sense that we're creating requirements or objectives, they're calling them here, and then we're doing analysis of those, we're developing a plan and a prototype and testing it, and then we're planning the next iteration. So it's kind of like a a whole bunch of waterfalls stuck into the Agile method. And then as we work our way away from the center, things get more and more specific, more and more built. But notice that if you, along the line going to the right, there are prototypes at every stage, just like there are with Agile. So this is kind of just a different way of looking at the Agile process. So changes toward the center of that cross, cheaper, changes toward the outside, more expensive. But then notice when we finally get to the end, we have code, integration, test, implementation, same things you have in the waterfall method, and then eventually release. But it kind of works its way out from the center, one thing at a time. So advantages of this, it's a little more formal than the Agile method, a little easier to document, has more formal planning involved, but still retains the flexibility of the other one. So problems with this, really the same kinds of problems with this that we have in the Agile method. Requires a relatively skilled team or a close-knit small team in order for this to work well. But this can work with larger teams where Agile can kind of fall apart a little bit on that. For example, notice that there's nothing here listing any kind of daily scrum. Notice back on this one, if you have a team of like 500 programmers, having a daily scrum where they all stand up and say what they're doing is going to be really impossible. Where this, you can still have documentation for the objectives, the risks, the plan for development and test, and then planning the next iteration. All of that can be documented with a larger team. So Spiral works a little better for larger teams, but has a little more formality to it. All right, the DevOps method. DevOps method is mostly used for things that have to rapidly change or things that have continuous improvement associated with them. So think of like a web service or an app. So you have some sort of web service where you want to add new features constantly. You want to constantly be changing things. And that's the real advantage of this, is notice that it's more of it's still cyclical, but it has like this kind of plan, code, build, test, release, deploy, operate, monitor, and then that leads into the plan. So it's kind of similar to what we had in the previous method, except we're actually releasing something and then looking at how it works and how well it does what it needs to do and monitoring that. And if there are things that need updated or additional features that are needed or performance improvements, then those feed back into planning, and then we code and build and test and release. And so this is like this constant set of releasing something, monitoring it, making changes, or planning to changes, making those changes, releasing it, monitoring it. So this is really good for ongoing systems like apps. Like you might think of something, even something like Facebook, where people are constantly using it and they're adding some new features and they're taking features away and they're improving things. This is good for something like that. Problems with this. The main problem with this is some systems just don't fit the model of constant improvements, and sometimes users don't want constant changes in their product. They don't want to have things move around on the user interface. They don't want to log in one day and everything has changed. So problems with this is it really is constantly releasing things that are then subsequently changed and re-released, and that can be problematic for some projects and some users. Imagine a game. You get used to playing a game a certain way, and then you log in the next time on the massively multiplayer thing, and then everything works differently. Or parts of it, the interface have changed around. And there are cases where that happens, and it can end up being irritating to users. All right. The next one, the Rad method, or Rapid Application Development Method, is really similar, except it's kind of like an Agile, but with a requirements planning phase up front, where you plan the requirements, and then you go into this construction / user experience, user design phase. So you build something, use it, see how it works, build some more, use it, see how it works. So again, there's a cycle there between both construction and users using it. And the main place I see Rad used is for custom development of projects for users. So in other words, the user comes to you, they say, I want a system that does this. You get the list of requirements from them and from your own input, and then you build something and they try it. And then they suggest the changes that you would make. And then you build something new, and then they suggest changes in that. And you do that until it reaches what's called the cutover. And what cutover is, that's the point where we can actually deploy it and no longer treat it as under construction. So cutover is kind of like you're turning it over to the user to now be the end product. So the advantage of this with a small team on a small project, this can go really quickly. The other advantage of this is it can directly involve the users or a user or a client that wants something built. You're directly involving them in the construction process and having them help guide the thing. So you can end up with a product really quickly. So again, if you build an entire thing and then you have them use it and then they want changes, very expensive, can be very difficult. But if they're involved in the process and you show them each step of the way, then what you get at the end is something that they wanted that suits their need more closely than if you just guessed at it. So very good for small teams with rapidly evolving projects based on a client or user's input. The disadvantages of this are one disadvantage I know from past history is sometimes users will have bad ideas. Sometimes they'll tell you they want something, and then you'll build it, and then they'll look at it and like, what is this? This isn't what I wanted. And so it's important to have good communication with that client or that user. It's also important to sometimes listen to what they say, but then maybe implement it a little bit differently than what they said they wanted, or listen to them and then suggest alternatives that are better if their idea is ultimately bad for the project. So sometimes you have to involve the user in a collaborative process, not in a prescriptive way. You don't want to do whatever they say because what the user or the client says is going to be bad for the project in the long run. Maybe makes constructing it more difficult. Maybe what they want is impossible. Maybe what they want is just stupid or a bad idea. And there's a better way to organize it that they just haven't thought of. So they're not kind of infallible. Neither is the developer or the programmer. So working together to kind of come up with what's best for the project makes a lot of sense. All right. So my thoughts, most of those other ones are cyclic in nature. You'll notice that there are arrows feeding back there. This feeds back into itself. That feeds back to the next iteration of the spiral. That feeds back into itself. The only one that's distinctly different is that waterfall method of top-down development. And the reason why that one's different is that's kind of this old-school managerial approach to engineering things, that you design it, then workers build it. And if your design was good, then what you'll get at the end was good. But the problem with that is software is more complicated than that. It's more nuanced than that in software development. A lot of times programmers will know better how something should be designed or can make suggested improvements to a design. And a lot of times even programmers themselves won't think of a better way to do something until you're partway through a prototype or partway through being done. And that's why all of the other ones focus on iterations. The other ones are all similar in that they have this iteration of prototypes, evolving the design, adding features, having a feedback mechanism that loops back to itself, monitors progress, makes course corrections. And because when you're software development is a really difficult task, that essentially you're building a really complicated machine. And that complicated machine that you're building has a whole bunch of moving parts. And if any one part is broken, the entire thing won't work. And so to do that, you kind of have to have this feedback loop. You don't want to spend 4 years developing a thing and then flipping the switch at the end and having it not work because the design had a flaw, or having it work but work and be bad or wrong or terrible. So the idea is that kind of evolving design, having the feedback loop is really critical when you're designing this. In other words, make a model, make a prototype, make course corrections, evolve the model, add features to it, check it again, try it out, test it, play with it. And then when you get toward the end, then you're going to polish everything up. You're going to finish everything off. All of the features will be done. The style of it will look how you want it to look. It'll act how you want it to act. It'll work correctly. And so I would suggest that Agile/spiral method of organizing your development. And there's one other thing I would suggest too that I've used here at my business, and that is a lot of times having pair programming or two people working together on code can make things go a lot faster. You would think that if you have two programmers, the best way to use them would be put them on two different tasks. But it turns out that having two programmers looking at the same code as it's being written and then switching out, kind of like tag team programming, can actually make things go faster, because one programmer who's driving or programming will explain what they're doing, and the other person can be looking at that, understanding it, asking questions, thinking about it, and then at some point you switch who's driving and who's kind of observing. So the idea there, it's kind of like a, I mean, I don't want to use this analogy, take it too far, but it's kind of like a sniper team. You have somebody who's running the hardware, somebody who's a spotter. And then you, if you work in that way, then you can switch off, and pair programming can actually work out really well. It also keeps them both on the same page with how things have been developed, as two programmers understand every piece of code. And sometimes that can be more efficient than dividing people up. But if you do divide up, make sure to communicate, make sure everybody knows and understands everything about the project. And for your projects, I would suggest that Agile method. And let me, before I finish up here, I've only got the kind of finalization slide. Let me just back up to that Agile method quickly. Notice that, again, we talked about design documents earlier. If you look at this product backlog section here, that could be stuff that's in your design document. And then you plan a sprint. This is what we're going to implement first and test. Everybody kind of works towards doing that and getting that first iteration done. Once you're done with that, you review it, and then you basically look at what it is and then make the next plan. Okay, now what are we going to fill in for the next sprint? So I'm going to take these next set of things, put those in the next sprint. We're going to add the next set of levels. We're going to add the next thing. We're going to start working on the art. And you can have concurrent ones of these working together. You could have a sprint up here for art content. At the same time, there's code content, or you could have server code in one sprint at the same time client code is going on. So you can have kind of concurrent parallel development going on with this, but the idea is at the end of that sprint, everything comes together. We look at it and review it. We decide kind of this retrospect. What do we need to make changes to now? Because we're going to build more stuff on top of this. We want to get it right now. And eventually that'll lead to everything being done. But use your design document as kind of a guide to think about what do we do first, get that done, check it, and eventually all of the things in your to-do list will be done, and that will be the end of your project. All right, that's all for today. Stay safe, wash your hands, stay inside, follow guidelines, don't go to the beach like an idiot, stay away from other people. And what we'll do next class is, like I said, we're going to dig into using versioning system software, which is going to be really important for working remotely on a project. We're going to look at kind of the concept of that, look at an example of how to get started with that. And then after that, next week, we're going to dig into some of those special programming topics. Okay, if you have any questions, shoot me an email, send me a text message, and we will figure this thing out together. All right, thanks.